we're going to continue looking at 1.2 practice problems, but we're now going to look at it from a different perspective. The previous worksheets, we had a graph, and I was just asking you specific properties of the graph, whether finding a limit or finding an ordered pair. But now we're going the other direction, which is a little bit more, takes a little bit more time to kind of get used to, is giving the properties and creating a graph out of these properties. Okay, we're going to sketch a graph, but it's not just going to be any graph, it's going to have to be a function. So we want to make sure that it passes the vertical line test, that we don't have any graphs that are overlapping each other and causing the function to, or this for the graph to not be a function. So that's something we need to pay attention to, that that we don't have any graphs overlapping each other. So let's look at these properties here and see if we can put this onto the graph in a way that is consistent with these properties. So the way I like to start these problems is I like to do the easy things first. So the easiest ones are the function values. So these are just points that sit on the graph. So I'm going to find those and get to them first. So f of -5 is -2. I just want to pinpoint, I just want to graph that order pair, -5, -2, onto my graph. So -5, -2. All right, that's easy. F of -1 is 6. I'll take care of that as well. Order pair, -1, 6. All right, so I'll check that off as well. F of 3 is undefined. So F of 3 is undefined. That just means that there's a hole or a vertical asymptote. So this we can probably save till later, because we can't pinpoint something that is not going to exist. So, okay. Now let's go back to number 1, okay, because we've taken care of all the order pairs that we can. Limit as x approaches -5 is equal to 3. So again, to review limit, that visually what the limit is that we want the path of the graph to move towards the same location. So on either side of -5, we want the graph to move towards 3. Okay. It doesn't mean that the graph is going to live at 3. It just means that it's going to move towards that y value of 3. So that means at -5, I want both sides of the graph to move towards 3. So what I'm going to do is I'm going to put a hole there, and I'm going to extend the graph a little bit on both sides, and I'll finish it later. But in the end, I want the graph to move towards that location, even though, if you look at number 2 here, even though the location is a different spot. So we want the graph to look something like this, right? Where the limit is existing at a different location than where the function value is. Okay. But right now, I just want to give a little bit of extension. And then after I see the big picture, I can decide where I want those graphs to connect to. Okay. Now, saying that, I will also highlight the fact that there are going to be different variations and still be correct. So there's a lot of different variations of this to be able to represent these properties on the graph and still be correct. Okay. All right, number 4 here. So I've taken care of this. I'll check that off. Limit as x approaches -3 is equal to -infinity. So what I want to happen here is I want both sides of the graph to move towards -infinity. So what that tells us is that this is going to represent a vertical asymptote. So I want the graph to look something like this, but instead of both graph moving up towards positive infinity, I want both graph to move down towards -infinity. Okay. So we talked about how -infinity, positive infinity, it technically it represents, does not exist, but this gives a very detailed description of how they want the graph, how they want the limit to not exist. It's going to It's not going to exist, but it's going to have to be specifically a vertical asymptote with both branches moving towards negative infinity. Okay, and that's something to keep in mind, is that if we see a limit for approaching negative infinity, it can't just be from the left side or just from the right side. It has to be from both sides. So I know at -3, I want to create a vertical asymptote. So I'm just going to highlight a vertical asymptote at -3. And I want my graph to move towards negative infinity on both sides. So I'm just going to give that behavior. I don't know exactly how the graph is going to look beyond it, but I'm just going to give enough, and I'll connect the graph later, but I know at least I want this to happen. I want the graph to move towards negative infinity, approaching that vertical asymptote from both sides of -3. Limit as x approaches 3 does not exist. So if a limit doesn't exist at 3, we have a lot of variations. Okay, we can either make it a vertical asymptote, we can make it two disjointed graphs moving towards two different y values. So this is a place where we're going to have potentially a lot of variations between different students, and that's fine. Okay, but just know that a lot of variations can exist if a limit doesn't exist. So I'm just going to create a situation where the limit doesn't exist. Maybe I can make a graph go towards one point and then make it pick off at a different point. Okay. I can make it a vertical asymptote. I can make it an endpoint. Okay. Now the last one, limit as x approaches 6 is equal to 4. So I want the graph to move towards 4 from both sides of 6. So I know my destination is order pair 4, 6. But I'm going to make it a whole, and just like with number 1, I just want to know where the graph is approaching. Okay. All right. So now I'm going to try to put this graph together, because there are some disjointed pieces all around here. And one thing that I noticed is that I extended this graph a little bit too far here. So I'm going to make this connected. Okay. And I want to connect these two parts together. So, and I can either make it an endpoint, or I can have this continue on. But if it's not described in within these properties, I can kind of, as long as I'm not conflicting with the fact that it needs to stay a function. And so we have a lot of room for interpretation for what's happening in between. So now let's go back and see if all these properties hold true even after we've done a little bit of cleaning up. So first off, limit as x approaches -5 is equal to 3. That's true, right? If I pick 2 points on either side of -5 and move towards -5, I have a consistent movement towards a y value of 3. F of -5 equals -2. That's true. F of -1 is 6. That's true as well. Limit as x approaches -3 is negative infinity. That's true. I want my graph to move towards negative infinity. It's going to fall into negative infinity from both sides. F of 3 is undefined. That's true. Limit as x approaches 3 does not exist. That's true as well. I see my graph is moving towards different destination as I move towards 3. Limit as x approaches 6 equals 4. Yes, from both sides of 4, both sides of 6, my graph is moving towards a y value of 4. I can make this point filled in if I wanted to. There's no restriction, but I'm just going to leave it as a whole. That's just my preference there.